Hello, hello, hello. Welcome to Circuit Playground Programming. Today we're going to be talking about flow control and some control flow statements that we can use to actually control the way that our program runs and do some more sophisticated programming and actually do some fun stuff. So let's get started. We're going to jump right off into the bat with what is flow control, if you don't already know. Now, I just like to start with a flow diagram here because that's the way that we can really represent flow in our programs and where things go. I started with a really kind of basic example that's really not related to programming, but a way to think about flow control. Maybe in everyday life, your brain uses flow control to figure out what it's going to do, in the same way that a computer is going to use the program that you write to figure out what it's going to do next or in the future. So here you can see I start my day off, then I ask a question, am I hungry? Now there's two options here. When I ask a question in programming, I have either the true or the false, which is yes and no in this case. If I am hungry, I ask, is it hot outside? If it is not, I will then get pho, and then I will wait and then come back. So there's like a loop structure here. I'm asking multiple questions. There's a couple different branches, and things are always looping back. So flow control is going to control the different branches of my flow in my program and also that looping that you see here. We're going to look at a couple different ways that can happen. So again, control statements cause the flow program to split into multiple paths. As you can see here, the hunger question splits into two, which then I am thirsty splits into two as well. So each of those control flow statements will actually split these programs into two different paths. This is also going to allow us to control the order of our code. Notice that this will continue to happen over time, and it's the same thing with any program that you're going to be writing with Circuit Playground. So let's go ahead and then let's start talking about the simplest one, which is just if, and else statements. We've talked about these in other videos about Python, and they're very similar in the Circuit Playground. They just have a little bit different syntax. But if you need a refresher on what they even do, these are actually going to allow us to control what happens as a result of a condition being true or false. So maybe if x is less than 10, we do something, or and then if it's x is greater than 10, we do something else. So the basic syntax is going to be if, and then we have a condition parentheses, open up some curly brackets, then code that will run if that is true. Then we have a second else if. This is how we ask multiple questions that are related. Then we have a second condition here, and then a code block that will run if condition 2 is true. And then finally we have our else, which only runs if neither condition 1 or 2 is true. So if this is false, it'll check this next condition. If this else if condition 2 is false, then it will finally go to this else, which just catches anything if these are false. Both of those are up here. So let's look at an example really quick. I wrote a script that basically is going to check the temperature of the Circuit Playground sensor, and it will set LEDs based off of that temperature. If you want to look in here, it says I have ranges of temperatures. It's honestly easier to look at this flowchart if you want to look at that. If temperature is between 0 and 15 degrees Celsius, it'll set the first LED to blue. Else if temperature is less than 0 degrees or freezing, it'll set the LED to white. If the temperature is between 25 and 40, I'm going to set the LED to red. If it's greater than 40, I'll set it to orange. And then if the temperature is between 15 and 25, I'm going to set it to green because this is the comfortable range, right? So that's all this code is doing right here, is it's actually going to be controlling this first LED based off of the temperature. So let's go ahead and take a look at what that looks like when we actually run it on the Circuit Playground. All right, so you can see here I have my Circuit Playground. Look at my code if you want to over here. This is the script that I'm using to actually set the color of the LEDs based off the temperature. And you'll notice that if I were to touch these, it's going to change colors. Notice that that's just sensing the color of, or the temperature of my finger, and it's actually changing the color of the LEDs as a result. So notice it changes to red, then back to green, and you could do that yourself, and you can make it a more sophisticated code. Maybe having each LED increase, showing the temperature. Maybe one LED shows 10 degrees each. So if it was 50 degrees in here, maybe 5 LEDs would be on. That might be something interesting to work on. But this is that example we just looked at for the if, else, and elif statements. Pretty simple example. Again, all I did was if the temperature changes, then I change the color of the LEDs. Notice it changes from green to red. All right, cool. All right, so the next type of flow control statement that we can have is called switch ... case statements. And all that is we have a variable that we are checking, and it's actually going to specify what happens when that variable reaches a specific value. which is different because with an if-else statement, we are checking maybe if x is less than 10 or greater than 10, or if it's greater than or equal to 10. Whereas with a switch case statement, we're actually asking what is the specific value of that variable, and then if it is those, we write cases for each of those values. So if we look at the basic syntax, let's say that we had a variable that could be 1, 2, or anything else. If that variable was 1, we would then do this. We would do something, maybe set that LED to a color, specific color or whatnot, and then we would break back out of this case statement. If the variable was 2, we say case 2, and then we do something when the variable equals 2, and then we'd also break out. Then if the variable was neither 1 or 2, again, these are values, right? So when that value is actually 1 or 2, if it were not, if none of those matches, then we would actually just break out of here, maybe have something happen. And switch case statements are really useful. And let's take a look at an example where we compare a switch case statement with an if, else, if, and else statement. So on the left here, we have our switch case statement. On the left, we have our if, else, if, and else statement. We're asking switch left press count. That's our variable that we'll be checking. And then we have 5 cases defined here for 0, 1, 2, 3, 4, and 5. So that's the number of press counts. If the left press count, if the button has not been pressed, then the LEDs are red. If the button has been pressed once, they're green. If it's twice, it's blue. Thrice, it's purple. 4 times, orange. 5 times, white. And then if it's anything other than 0 through 5, if we pressed it one more time, we're actually going to go to this default where we'd reset that left press count to 0 and then break off. Now, with the if, else, if, and else statement, it's a little bit more complicated, honestly. We ask if left press count equals 0, then we set the LEDs to red. Then we ask is it equals to 1, the equals 2, equals 3, equals 4, equals 5. And notice there's all these curly brackets that we can go wrong with. There's these double equals that we could go wrong with. We might accidentally, this just looks messier to me. And then we also finally have our else statement, which is when all of these are false. And then we reset that left press count to 0. As you can see in this case, honestly, the switch case statement is a little cleaner and a little easier to work with. There's less room to go wrong. So I would prefer a switch case statement when we're checking maybe integer values of a variable that are increasing by 1. It makes things really easy so we can set a case for each of those values. Much easier than maybe in this if, else statement structure. Notice that all of these cases are inside of these curly brackets. So there's only one set of curly brackets here as opposed to a curly bracket for each condition we're checking here. And again, we're just checking the value of the variable we put in the parentheses, and then we're defining cases or what happens when that value is those, or variable is those values. All right. So that's switch case statements. I just want to really briefly cover those. Let's go over some more complicated, more useful structures like, well, for loops. Now, for loops are super important, and you're going to use for loops a lot. Let's talk about what for loops are. So they're a very powerful flow control structure, used when you want to repeat a block a specific number of times. So let's look at the syntax really quick. We have the for word, obviously. Then we open up some parentheses. Inside the parentheses, we're going to have our initialization, condition, and increment. And then inside is the statement that we're going to run. And we'll look at a specific example, but I first want to talk about what each of these are. So the first thing is the initialization. This is going to set the initial value of that variable that is going to change in the for loop. That's going to determine how long this for loop is running and also what is changing in the loop, because something needs to change, otherwise the loop will run forever. The condition is an expression that is either true or false. This is just like the conditions we check in if, or else statements. And this condition that we put here will specify when the for loop runs. So if the condition is true, the for loop will run. If it is false, the for loop ends. So this controls when it ends, initialization controls when it starts, and then increment is actually going to control how that variable changes over time as we iterate through this loop. So it's going to change that variable with a specific value. So this is going to be, initialization is the starting value, condition is the ending value, and then increment is how that value of that variable changes over time. And then statement in here is just honestly going to be whatever we want our for loop to do as it iterates. So let's look at an interesting example here. Let's look at if we wanted to set all of the colors of the Adafruit Circuit Playground to one color instantly. So the first thing we'd want to do is declare a variable. It's going to be, this is in our initialization. We'll say int LED num equals 0. So we're going to start off with the first LED here. If you look, notice that LED num is used inside of the CircuitPlayground.setPixelColor function as that first input, which controls what LED we're turning on. And so if we want to turn the first one on, we need to start it off as 0. The second thing we're saying is that LED num needs to be less than 10. So remember, this needs to be true for the loop to run, which it will be starting off, right? LED num equals 0. It will stop when LED num equals 10, which would be right after the last LED is turned on. Then our increment is LED num plus plus, which just increases the LED num, this variable, by 1 each time we go through the loop, each time we iterate. So now, LED num is going to start off at 0, going to set that first LED to red, then it's going to increment by 1, go back up to the top. Now LED num equals 1, then LED num will, that second LED will set, it'll continue until we get to LED num equals 10, which LED num equals 10 does not exist, at which point that for loop will end. Got a nice little flowchart over here if you want to look. It's just asking if this is true or false. Then we set that LED to red, increase LED num by 1, go back up to the beginning until LED num is not less than 10, and then we end our code. So let's go ahead and take a look at what that looks like. I have a little bit more of a sophisticated example where I use multiple for loops, and you might be interested in seeing what that looks like. All right, so I have my Circuit Playground set up on a for loop right here, which you can see is being shown. I actually put a delay in between each if you want to look at my code here. I have 3 different for loops. One that is this one right here that is increasing from 0 and going up by 1. Notice there's a delay here. And then I also have one starting at the end and going backwards, and then another one starting at the beginning and going forwards, which you can see if you want to take a look. See, it's going there and back and forth. It's kind of a cool little pattern. You can do a lot more sophisticated patterns if you want to, but this is just a nice little basic pattern with only 3 for loops. Notice how much easier it is with for loops over the copy pasting it so many times. So this makes your lives a lot easier. All right, so the last type of control flow structure I want to talk about is the while loop. The while loop is actually very simple, and it's a little more versatile, but it's also going to be, with that versatility comes some difficulty in using it. What a while loop does is it continually loops until a condition or expression inside that parentheses is false. So if we look at an example that is identical to the for loop, you'll see that it's has a little bit more lines of code, but it has the same result. So if we look here, we're starting out LED num equals 0. And we say while LED num is less than 10, notice this is the initialization here. This is the condition we're checking. Then we say CircuitPlayground.setPixelColor, LED num, less, comma 255, comma 2, comma 0, comma 0. Then we have to increment our variable LED num plus plus. This is the identical to our for loop that we just looked at. Notice though we have separate lines of code for each of those, the initialization, the condition, and the increment. Whereas the for loop has all of this in one line. So if you're going to be doing anything that has a set number of iterations, you would want to use a for loop. Whereas with a while loop, it's more for open-ended loops that you might not know when the condition is true or false. That's where we'd use it. And we'll look at some more examples later on when I do a future video on more specific applications. But if you look here, if I took out this LED num plus plus here, what would happen is num starts off as 0, and I took this code out, so if I just went ahead and let's say that I just went ahead and, give me a second here, let me get my highlighter out and just block this off. That's yellow. Whoops. So let's just say I took this out of here. It's gone. Now, you might wonder what's going to happen now. Nothing good, I can tell you that much. All that's going to happen is LED num is going to be 0 the whole time, so we're going to be stuck in an infinite loop, and LED num will always be 0. So then we're just going to be setting that first LED to red forever, which is not particularly exciting, and I would not recommend you do that, right? So with while loops, it's easy to get in an infinite loop scenario where something might run forever. Whereas with a for loop, we have a finite number of iterations. A while loop can be open-ended and can be infinite at times if you're not careful. You sometimes want that to happen though, like in the case of the loop function that we have. The actual void loop function we've been using, that is actually an example of a infinite loop, right? Because that's going to be repeating as long as the Circuit Playground has power. So those are the control flow statements. Again, we have our If-else statements, we have our switch case statements, we have our for loops, and our while loops. These are the basic ones that I want you to know, and feel free to ask any questions, and happy programming.